Hello class, this is the video for section 5.5. Now I want you to know that this section, there is no homework, but it reviews the properties of logarithms, and therefore it's worth going over before we get to 5.6 and then 5.8, because we're going to be using the property to solve equations. Okay, and it talks about properties of logarithms. Our learning objectives are the following. We work with some properties. We write a logarithmic expression as a sum or a difference. It is a property. And then also writing that as expression as a single word logarithm. And then evaluate some logarithms, okay, either with base 10 or base 8, especially when the base is not e or 10. If it is true, how do you evaluate that using your calculator? Okay. So now we want to show that this is a property, that the log of 1 base a is equal to 1, and then the natural log of 1 is also equal, so it was equal to 0. The natural log of what? 1 is also equal to what? Is equal to 0. Okay, how do we show that? And then how do we show that the log of what? A base a is equal to 1, or natural log of e is equal to 1. So let's start with the first one. All right, we have the log 1 base a is we want to show that is equal to what? Is equal to 0. So first we want to let, okay, we will let the definition, the log of 1 base a is equal to what? Is equal to certain value, let's say y. Okay, now by the definition, what must we raise the base a to get what? To get this 1. Okay, so we can write as an exponential function. This will be a raised to y is equal to what? Is equal to 1. Okay, now we know that 1 is equal to, is always the same as what? The same a raised to 0, and then what? A raised to y. So this means that y is equal to what? Because the bases are the same. Therefore, the log of 1 base a is equal to what? Is equal to 0. Now similarly, okay, if I have natural log of 1, okay, we say it is equal to what? Is equal to 0. First, natural log is the same as log to the base what? 1 to the base e. So we'll let this equal to what? Y. Okay, and then we write it as exponential function. Okay, expressed as exponential function. So this is what? This is y. E raised to what? Y is equal to what? Is equal to 1. Okay, and then the 1 is the same as e raised to 0, because anything raised to 0 is equal to 1. So this get e is equal to y, and therefore you get y is equal to 0. So we have shown that the log, natural log of e1 is equal to what? Is equal to 0, or simply natural log of 1 is equal to what? 0. Okay, now for part B, it said log of what? A, base a, we want to show that is equal to 1. We do the same thing. We'll let the log of a is equal to, say, x or y. It doesn't matter. Okay, so this means that by definition, what must we raise this base, okay, to get what? To get a. All right, so it will be what? A raised to what? X is equal to a. And of course, this is equal to 1. That means that x is equal to 1. Okay, similarly, right? Similarly, if you have natural log of e, we want to let it, we want to show that is equal to 1. Okay, we do the same thing. Natural log of e is equal to x, and the natural log of what? E is the same as log to the base e. Okay, log e base e is equal to x. Then we write this as a e to the x is equal to e, and of course this is equal to 1. Therefore, x is equal to what? 1. So we have shown that log of what? E base e is equal to 1, and then log of what? A base a is equal to 1. That means that it's a property that when you take log to the same base, it's always equal to 1. And if it's a log of 1 to any base, it's equal to what? 0. Okay, that is for the part what? But the part A we just described. Okay, so if I give this example, okay, what is log of what? 1 base 10. This is what? This is 0. What's the log of what? 1 base 2. This is equal to 0. Now, what is log of what? 2 base 2? This is 1. Or log of what? 8 base 8 is equal to what? 1. Okay, so that's the property. Now, second property is that, okay, when you have, okay, you have what? A raised to log of m base a. Now, when this a is equal to this base, the answer is equal to what? Is equal to m. Okay, the same way, if you have what? Log of a raised to n base a is equal to what? The exponent as is given. Okay, so that is from one of the properties that we'll be talking about. We can write this, the second one, we can write it as r log a base a. Now, what is log a base a? That is what? 1. So to get r times 1, which is what? R. That's why we got that. Okay, so now let's apply this to certain what? Certain examples, right? The first two. If we have 3 to what? Raised to log pi base 3. Now look at this. This 3 is equal to what? That base. So this is actually is equal to what? Pi. As simple as that. Okay. The second one, log of 7 raised to what? Log of root of 3 base what? Base 7. That is equal to what? Log of what? Square root of 3. And then this one also equal to what? Negative 4, 13. Okay. So, but the same what? The same reason. Okay. All right. All right. So if you have a log, that is a product. So that's a m, a is not equal to 1, and r is any real number. Okay. Okay. Now m and n are what? Are any what? Positive what? Positive real numbers. Okay. If we have a product that is m times n, then we can write it as what? As a sum. So that is the log of m base what? A plus log of what? N base what? Base A. Now this is going to the from what? Left to right. Now if I have this, I can write it as a single. If you have plus, you can write it as a what? As a single, which would be a product. So in other words, a product becomes a sum of logarithms. Now sums of a log will condense to what? A product. Okay. On the other hand, if you have a quotient like m divided by n of what? Log of that with a base what? A, then this becomes what? A difference. Okay, it's the same thing, but this is the difference. And then on the other hand, if you go in this way, you can write it as what? As a quotient. If you have the negative between two logs that have the same base, then we can what? Write it to condense or write as a single logarithm as that. Okay, so it is very important to note these what? Properties. Okay, now the other property is that we just talked about this, right? That the log, okay, m is a positive integer or real number, sorry. A is not equal to 1, r is a real number. So it said the log of a power equals the power, the product of what? The power and the what? And the logarithm. Okay, so when you have what? Log of what? M raised to n, then this becomes what? R times what? Log of m base what? Base A. Okay. Now, on the other hand, if you have a raised to what? R is equal to e raised to r times what? Natural log of a. Okay, from the properties 2 that we talked about, we can write this as what? E raised to a natural log of what? A to the r. And that is why this becomes a to the r, and which is what? Which is that. Okay. All right. Now, writing logarithm expression as a sum, all right, or as a difference. Now, we'll write log x squared times square root of x plus 1, the base what? Base a, where a, the domain is a is what? X is greater than 0. Okay, We want to write this as a sum. All right. Now, why? This is what? This is a product. It is x squared times the square root of x plus 1. Okay. Therefore, if you want to write as a sum, this would be what? This is a log x squared, the base is a, plus, okay, log the square root of what? X plus 1 to the same base, what? Base a. Okay, so we are using this product, that property. Now, but if you have an exponent from the property 6, okay, from this property, we can write this as each of these. But before even that, because it's a square root of x plus 1, we can write it as what? X squared base a. That could be written as what? Okay, log x plus 1 raised to what? 1/2. Okay, so then I use the property that says that if I have log m raised to r, then it becomes what? R times the log of that. Okay, so then this becomes what? 2 log what? X base a plus what? 1/2. Okay, this half comes to the what? To the front and becomes what? X plus what? 1. Now we cannot write this. This is x plus 1. It is not x times 1. So that we write it as what? Log of, we use this property as a sum. Okay, so that will be your final what? Final answer to that. Okay. All right. Now, as a quotient, okay, say x is greater than 2 because the denominator cannot be 2. Okay. So if you want to write this, okay, first we take the natural log of what? X squared divided by x minus 2 raised to what? 4. X is greater than what? Greater than 2. Now, because log is dividing, we can write it as a difference. Okay, so this becomes, we use this property, becomes minus, which is what? Natural log of x squared minus natural log of what? X minus 2 raised to what? Raised to 4. Okay, so then we use the what? The property, this same property again. It becomes what? 2 natural log of x minus 4 natural log of what? X minus 2. Okay, and that becomes your what? Your final what? Your final answer. Okay. All right. Now let's go to the next example. Okay. Now here is a combination of what? The sum and then the difference. Okay. All right. So we are given the log of what? Cube root of x squared plus 2 divided by x squared times x plus 2 all squared to the base what? Base b. Okay. Now there are a couple of things that we can do this. First, we can write as a what do you call it? I can write the cube root also as exponent. Okay, x squared plus 2 all raised to 1/3. So let's write this that first. Log to the base b. Okay, and then the numerator becomes x squared plus what? 2 raised to negative positive what? 1/3. Then divided by x squared times what? X plus 2 all squared. Okay, so then we use the quotient. Okay, we I just apply this this property. Okay, so if I have r base a, then this becomes what? Log m raised to r base what? For that. Then we can use the quotient formula. All right, when you have a quotient, becomes what? The minus. So this becomes what? Log. Okay, the numerator is what? X squared plus 2 raised to 1/3 base what? B minus log x squared times x plus 2 all squared. Okay, base what? Base b. Okay, so we use the what? The property which says that log of what? M over n is what? Log m minus log n. Okay, so then we use this property again. But before that, let's look at what? This is a product. Okay, so put that in what? That's a product. That's a product. So we're going to write as a sum. So that becomes log x squared plus 2 raised to what? 1/3. The minus, okay, you want to put that in parentheses. That becomes log x squared base b plus log x plus 2 all squared base b. Okay. All right. So we use the sum. This is what log of what? M times n is what? Log m plus what? Log n. All right. So then we use this property again. And then we have what? That should be 1/3. Okay. Log, don't forget your base. Okay. The base is still b. Log what? X squared plus 2. Now this is going to distribute that. That becomes negative of 2 log x base b. Then minus what? 2 log, that's log what? X plus what? 2 base b. Okay. So that is our final what? Answer. Okay. All right. So then, going the other way, you remember the rule is that if you have a log of what? M times n, it becomes what? Log m. Sorry. Let me erase that. Okay. It becomes the sum. But if you have the sum, you can write it as what? As a what? As a product. Okay. So you're going what? From right to what? To left. So this becomes log what? Log m minus log of what? N. Okay. And if you have the difference, if you have what? Log m divided by n, then this is plus actually. It becomes what? Log m minus log what? Log n. Okay, so we're going to apply that, write it as a single. If you have the sum, it becomes what? If it is sum, that becomes what? It becomes a product. If it is minus, it becomes what? A division, right? Okay, but we don't have to forget this property too. That says what? Log of what? M raised to n r base a, or whatever base is equal to what? R times what? Log m base what? Base a. Okay, so if you have that, let's see the first one. All right, first, this is 3 times. So we use this property. All right, we use this property here and write it as what? Log of what? 2 raised to 3. Okay, so this becomes log 5 base what? Base b plus log 2 base b raised to what? 3. Now, I can do that because I have what? I have the same base. If they don't have the same base, you cannot apply what? The property. Okay, now it's a sum. We can write as a product. So that becomes log, okay, base b, and then get 5 times 2 raised to what? 3rd, like that. And then which is equal to log 5 times what? 5 times 8 base b. And that is what? Log 40 base what? Base b. Okay. So we can write, if you have a sum, it becomes a product. If you have a difference, it becomes what? A quotient. All right. Okay. Now let's look at, that's the properties that we apply. Okay. So we got this. Now let's go to part B. Now let us notice that this is what? Natural log. So the base is E for both of them. All right, for both of them. But we will use the first property. Now because it's what? 2/3 times that. Okay, first thing is that I want to write there's a natural log of 27 raised to what? 2/3 minus natural log of what? 6 squared minus what? 9. Okay, so if you do that, then this becomes what? Because now, because it's minus, we can write as a division. Okay, so we use this property, that is what? R, okay, log of M base what? Base A is equal to what? Log of M raised to R base what? Base A. Okay, so now we can write as a natural log, okay, of what? 27 raised to what? 2/3, okay, divided by 6 squared minus what? Minus 9, like that. Okay, so which is what? Natural log of what? 27 raised to what? 2/3, okay, divided by 30 what? 6 minus 9. All right, now we can simplify that. What is 27? Okay, if you have 27 raised to what? 2/3, this is the same as what? 3 raised to what? To the third, all raised to what? 2/3. Then when you use the laws of exponents, this becomes what? 3 raised to what? Raised to 2. Because you have what? You get 3 times 2/3, and that cancels out. So you get what? 3 squared. Okay, so the numerator there is natural log of what? 3 squared divided by 36 times what? What is that? 36 minus 9 is actually what? 20 is 27. Let me see. 36 minus 9 is what? It is 27. Okay. All right. So this gives us what? Natural log of what? 9 over what? 27. And which is what? Natural log of 1 over what? 1 over 3. Okay. So look at it. It becomes natural log of 1 over 3. Okay, so it expresses as a single. So this whole thing becomes natural log of that. But you notice that this is the same as natural log of what? 1 minus natural log of what? 3. Okay. But, okay, natural log of 1 is equal to 0. So this is nothing but negative natural log of what? Natural log of 3. Okay. So that is it. Okay. Because that is equal to what? 0. So that's the answer. Okay. So we can express and then simplify because these are all numbers. Good. Now, the last property, which we will use in 5.6, okay, solving equations, very important. These two, very, very important in solving equations. So if you have an equation, m is equal to n, again, we can take natural log on both sides as that. On the other hand, if you have the log of m as an equation, all right, then we can drop off the what? We can drop the function, the log, and get it as what? M is equal to n. All right. So here's the one example. It said express y as a function of x. Okay. Now, if I look at this, I have plus between the what? The terms. So I can write the right-hand side as a product. So this would be natural log of what? X times x plus what? 1 times what? Times c. And I have natural log of what? Y. Now, by that property we just talked about, this becomes, this will kind of cancel out. You have what? Y is equal to what? X. So x times x plus what? 1, and then times what? Times c. Okay. So that becomes what? That is the function expressing y as a function of what? As a function of x. Okay. And then finally, all right. Now, sometimes if you are given, say, log of what? Let's say log of 16 okay, over log 2 of 16 over 5. Now, how do you use your calculator? How to use the calculator? How do you use the calculator to do this? Now, the only thing we can do this is that we change, because the calculator comes with what? Either base 10 or base E. Okay, so in this case, we just have to change the base to what? Either base 10 or base what? Base E. And whichever you use, you get the same what? The same results. Okay, so if I have A is not equal to 1, B is not equal to, and M is a positive real number. Okay, if you have log of M base A, now I can change the base to base B, and it will be what? The log of what? The M base B divided by the log of the base, okay, the A base what? Base B. Okay, now if you change it to natural log, then that becomes what? Natural log of M divided by what? Natural log of A. Now, like I said, whichever one you use, you get the same what? The same results. Okay, here is an example. Okay, I have what? Log of 52 base 7. Okay, I cannot use a calculator directly unless I change the base. All right, so let us see how we will do this. Okay, I can change the base to base 10. Okay, let's change it to base 10. All right, and say that this is what? This is a log. That's a common logarithm, is what? 52 divided by log 7. Okay, now you use your calculator and you have what? Log 52. Okay, this kind of gives me 1.716003344 divided by log 7, which is 0.84509804. Now, if you divide this, it is approximately equal to what? Equal to this value. Okay, now I could have changed it to what? Natural log. All right, same function there. I change it to it as a natural log. So this will be a natural log of 52 divided by natural log of what? Natural log of 7. Okay, so change it to either base 10 or base what? Base E. So 52 divided by natural log of 7. Okay, what would this be? So on the Mac calculator, I punch in what? Natural log of 52. Okay, which will give me 3.951243719. Okay, divided by the natural log of 7. Natural log of 7, that is what? 1.945091049. Okay, when you divide this by that, that should approach what? The same value. Okay, so as you could see, doesn't matter which what natural log what the base that you change to, either a base 10 or base E, you get the same what results. Okay, the second one, all right, we can change it to base 10 as that. All right, that would be log square root of 7 divided by log square root of 3. And then when you approximate it, that gives me 1.7714 to 4 decimal places. Okay, and then on the other hand, if you change it to the what? To the natural log, that becomes what? Natural log of root of 7 divided by natural log of 3, and that approximates to the same value. Okay, so with that, that is the end of this section. I hope this is helpful, and I'll see you guys soon.